So in this question, we have a car which wants to cross the bridge. Initial velocity of the car is 0. The friction coefficient between the tires and the road is 1, and it has to cross 500-meter long bridge. We need to find out the minimum time the car will take to cross the bridge. So for this question, we first find out what can the maximum acceleration of the car be. So we first need to find out what external forces are acting on the car, because it is only the external forces acting on the object which determine the acceleration of the object. Internal forces never take a part in determining the acceleration of the object. So the only external force acting on the car in horizontal direction seems to be the friction force. The only horizontal force acting on the car is the frictional force. Now the maximum value of this frictional force is equal to mu into n, that is equal to mu into mg, because the normal reaction is equal to mg. This is the maximum friction force that can act in horizontal direction so as to provide the maximum acceleration. So when mu mg acts here, the acceleration of this object is a, so mu mg becomes equal to ma, so acceleration becomes equal to mu g. If the frictional force, static frictional force, is less than mu mg, then the acceleration is less than mu g. But since we want the minimum time, we will take in maximum acceleration. So the initial velocity of the object was 0, displacement is equal to 500 meters, acceleration is equal to mu g, let time equal to t. We use s is equal to ut plus half a t square. Now here we know initial velocity is 0, therefore s is equal to half a t square, 500 is equal to half mu g, that is equal to 1 into 10 into t square, this becomes 500, therefore t is equal to 10 seconds. So final answer is 10 seconds, and that means the car cannot cross the bridge in less than 10 seconds.